Today's question is, how do we embed values into autonomous system in a way that's technically workable and ethically defensible? For this lesson, I'll use IEEE's Ethically Aligned Design EAD as a reference. EAD is easiest to understand as a contrast. It's a practical reference for design and governance choices, but it isn't an IEEE policy, a professional code, or law. So we use it as a guidance, not as a rulebook. So here's why this matters. This matrix uses two axes, technical performance and ethical alignment. The goal is the top right corner, high tech and high ethics. In the bottom right, we have efficient but harmful. These are high performance, but ethically have quite a weak groundwork. The bottom left is unusable and unsafe. An example would be Taybot. Tay was Microsoft's Twitter chatbot that was rapidly steered into racist abuse, showing what happens when capability and guardrails are both inadequate. Top left is our well-intended but ineffective, things like medical symptom checker chatbots and early Siri. The symptom checker chatbots are health triage robots that can misclassify risk without actual clinical context. In safety-adjacent settings, mostly works, still isn't dependable. Top right is our trustworthy deployment target. As you can see on the overlay, this is the definition of responsible research and innovation, RRI, that aren't just efficient, but achieve social desirability. A really good example is the Waymo driver, which is a self-driving taxi service that treats safety as an explicit engineering practice, compared to companies like Tesla and their autopilot. So how do we move towards the top right? EAD gives 5 principles, but the key is to treat them as design checks. Human rights are obviously the most important, and we can't ship any products without protections. Does it actually improve people's lives in a safe and fair way? Who owns it when it goes wrong? Can we explain and audit what it did? And how will it be abused? And what can stop that? Think of these as testable requirements. If any of these questions can't be answered, then it isn't checkable and it isn't deployable. The EAD warns that autonomous and intelligent systems, AIS, ethics, can get dominated by a single, often Western valued tradition. This risks blind spots. For instance, Western ethics often splits the world into moral agents, who act, and moral patients, objects acted upon. Other traditions challenge this. In Buddhist tradition, ethics is framed relationally. The self is less central than the relationship between entities. The key takeaway here would be to use relational ethical statements alongside Western methodologies. In the Ubuntu tradition, personhood is relational. A person is a person through other people. You must design with communities, not just for them. In Shinto tradition, the artifacts and automata are treated as a part of nature in a relationship-centered view. As the citation overlayer notes, Masahiro Mori argues this challenges the binary between agent and patient, suggesting robots can be partners and not just tools. EAD also names Aristotelian, Kantian, and Confucian traditions. They're useful context, but I'm limited for time, so I won't cover them here. Here's the key comment. Responsible innovation becomes biased when one ethical tradition dominates design standards. As noted on the overlay, Pak-Hang Wong identifies this as a risk of delegitimization. When standards default to Western values, local values are effectively erased, barring those innovators from the global network. So the next step is operational. We want to translate values into explicit norms, then implement, evaluate, and update transparently. Plural ethics is a robustness requirement, not a cultural add-on. So let's explain how to embed values. As the overlay indicates, this mirrors Friedman's value-sensitive design methodology. We start with abstract values, things like fairness, dignity, but they're difficult to encode directly. So we translate values into explicit norms, concrete, testable rules. Then we follow the cycle, identify norms, implement computationally, and evaluate conformity. When context changes, we loop back, because we want norms to be maintained, not sent once and forgotten. So here's how we wrap this up. Values to norms to evidence. Values like fairness, dignity, and safety don't compile, norms do. VSD helps you translate values into explicit norms, for example, process data on device and delete logs after 24 hours. Then EAD turns principles into design checks, auditability, traceability, ownership, monitoring, so you get evidence, not just intentions. So the next step is to choose stakeholders, write measurable norms, and keep the checks running. So ethics isn't a feature, it's a loop. What norms would you write, and what evidence would convince you they work?